4.4, executing other programs. We're going to look at how to run a program and wait for it to finish, or how to run a program in the background while our code is still running. We're going to see how to interact with programs running in the background, and then we're going to write the next step of our project. Making other programs run used to be something of a mess. There were different mechanisms that worked on different platforms, there were mechanisms that were convenient, and then there were different mechanisms that were secure. Fortunately, that all changed in Python 2 version 2.4, with the introduction of the subprocess module, which abstracts away the differences between platforms and makes the more secure paradigms easy to use. There are 5 objects in the subprocess module that are of particular interest. 3 of them are the call, check call, and check output functions, which are 3 variants of the same basic idea. They run a program, wait for it to terminate, and then tell us something about what the program did. The call function returns the program's exit code. The check call function raises an exception if the program's exit code was non-zero, which by convention means that it exited with an error. The check output function returns whatever text the program printed, and raises an exception if the program exited with a non-zero exit code. The raised exception has an attribute called output that contains the text output of the program, so even if the program exited with an error code, we can still get the output if we wanted. The 3 call functions are invoked largely the same way. Each of them is passed a list containing the program name and its arguments. The check output function has a noteworthy keyword-only parameter called universal newlines, which defaults to false. If we set universal newlines to true, the text output of the program is decoded into Unicode characters using the system's default text codec, and newline characters are normalized. If we leave universal newlines at its default value of false, the program output is returned as bytes, and it's up to us to do any decoding and to deal with whatever sequence of characters the current system considers to be a newline marker. If we want to get fancy with our running of other programs, we'll want to use the popen class, the 4th interesting thing in the subprocess module, which allows us a great deal of flexibility and control over the execution of other programs at the cost of a bit more complexity. The popen constructor accepts the same list of program and command line arguments as the call functions do, and a very large number of optional keyword arguments, including universal newlines. We're going to focus on a particular use case of popen that is useful, but goes beyond what we can achieve with the call functions. We're going to see how to run a program in the background, while our own code is running in the foreground, and send and receive data between the 2 programs. To manage that, we're going to need the last of our 5 interesting things from the subprocess module, the pipe constant. The pipe constant is used in conjunction with the standard in, standard out, or standard error keyword argument parameters of the popen constructor. These parameters represent the other program's textual input, output, and error reporting, and any of them that we set to pipe are redirected to our program. In this example, we're redirecting the program's input and output to ourselves, which gives us a bidirectional data channel with the other program. Once we have pipes set up, we can send data to the other program by calling the write method on the popen object's standard in attribute, and we can read data by calling the read method or its relatives on the popen object's standard out attribute. Note that these are input and output as from the perspective of the called program, the subprocess, and therefore sort of backwards from the perspective of the program that's running in the foreground. In spite of disabling buffering with the buff size equals 0 parameters in this example, it's usually a good idea to call the flush method on standard in after writing to it, and the flush method on standard out before reading from it. We can keep on sending and receiving data for as long as both programs are running, but if the time comes when we're done interacting and we just want to wait for the other program to terminate, we can call the popen object's wait method to do that. The wait method will return the exit code from the other program once it's done running. A lot of the complexity of working with piped standard in and standard out is wrapped up in the popen class's communicate method, which accepts input as a parameter and returns output. Communicate is simple but somewhat limited because it can only be called once for each popen object, and doesn't return until the other program finishes. That isn't any good for 2 programs that need to talk back and forth to each other, but it should be just perfect for our pipeline program, where each program receives the output of the previous program as its input. We're going to create a bunch of classes to represent the different kinds of steps that can take place inside a pipeline stream, and integrate classes into the interface as well. Once we've done that, the program is functional, though there's still plenty of room for improvement. We've got our example program working, so the call, check call, and check output functions of the subprocess module give us an easy way to run other programs. If we need more control over the other program, we can create a popen instance to interact with it. The popen methods pull, wait, communicate, and terminate are particularly useful. So we're going to move on to the next topic of this section. setting up a shell script or batch file to launch the program.